All right, y'all, today we're going to start Unit 8. Unit 8 is all about graphing quadratics. Now, as you're writing that at the top of your notes, you're probably asking yourself, what is a quadratic, Smith? Well, here's the thing. It's just what's next. We've done two major types of functions so far. The first one that we talked about first semester was something like y is equal to 2x. And this, hopefully you know what kind of shape this would make if we graph it. It would make a line, but instead of making a line first, we're going to make a table of values, x, y. And x, I'm going to go with 2, 1, 0, -1, and -2. So the table of values is just saying, hey, listen, if x is 2, then what is the value of y? So if I plug in 2 for x into here, 2 times 2, of course, is 4. And then 2 times 1 would be 2. 2 times 0 is 0. 2 times -1 is -2. 2 times -2 is -4. So we just made a table of values of a few things, and then if we were to graph this, I'm just going to make a quick little sketch. Nothing crazy. You don't got to go too precise or anything. Now, when we were graphing lines, y is equal to mx plus b. So since there's nothing here, what is being added here? Hopefully you realize that it's 0, right? In fact, look at our table of values here. Our starting point is the point 0, 0. And our slope is 2, so it could rise 2, run 1, rise 2, and run 1. But, sure, I'm going to plot these points. I got the points 2, 1, 2, up 4. I'll put it right there. So, run 1, up 2, and then I got the point 0, 0. But then I could go -2, or excuse me, -1, -2 down there, and then -2, -4 down there. Hopefully y'all remember that that would make a line. If I have y is equal to 2x, the exponent of x is 1. Not that that matters right now, but yeah, that would make a line. Then last unit, the one we just took a test on, was y is equal to 2 to the power of x. Right? That was an exponential function. And if we were to make a table of values here, I get x, y, 2, 1, 0, -1, and -2. If we were to make a table of values here, if I take x, if I plug in 2 for x, what is 2 to the power of 2? That'd be 4. 2 to the power of 1 is 2. Hey, look at this. It's the same as before. But 0, what is 2 to the power of 0? Yeah, hopefully I'll remember that that is 1. All right, so here was a tougher thing. 2 to the -1. Remember what that would look like. That would look like 2 to the -1 power. But negative exponents would bump and become a fraction. That would be 1/2. Remember that? 1 divided by 2. And then 2... that's this 2, to the -2 power, that would be 1 over 2 to the 2, which would be 1 over 4. Right? Great! So, if we were to graph this, actually, before I graph this, let's go back here. What if x was 3 on this one? What's 2 times 3? Well, that would be 6. What if x is 3 on the exponential? What is 2 to the power of 3? That would be 8. Anyways, that's just a little difference. Let's sketch this real quick. Plot these points. I got the point 2, 4. So 2 up 4. I got the point 1 up 2. Then I got the point 0, 1. That would be something like right there. -1 would be a half, like right there. X is -2. Y is 1/4. Going down like that. What about, let's go back here. If x is 3, this is the point 3, 8. 3, 8 would be, whoa, like way up here. This was an exponential growth curve. Remember this from last unit? Looking like that. So those are the two major types of functions that we've talked about this far. Linear makes a straight line. We talked about exponential. Makes this curve thing like this. But today we're going to start talking about quadratics. And that's going to look something like this. Y equals x squared. Y is equal to x squared. So before the 2 for linear, it was y is equal to 2x, exponential x was in the exponent. Now x is the base and 2 is the exponent. Let's make a table of values of this real quick. Let's see what's happening here. I got x, I got y. 2, 1, 0, negative 1, negative 2. Hey, fill in this table of values real quick. What is 2 squared? That would be 4. 1 squared would be 1. What's 0 squared? 0. All right, careful here now. What is negative 1 squared? Well, negative 1 squared means negative 1 times negative 1. Negative times negative is positive 1. And negative 2, 0 would be, or excuse me, negative 2 squared would be positive 4 again. Just for fun, what would negative 3 be? What is negative 3 squared? Hope you all got that's 9, yeah? Great! Let's make a sketch of this. Let's see what this is going to look like. Plot these points. I got the point 2, 4. This time it's a little different. 1, 1. Here I got the point 0, 0. Negative 1, positive 1. Negative 2, positive 4. And if I go negative 3, up 9 would be right there. Hey, what do you think 3 would be? 3 squared would be positive 9 as well. So look at this weird shape. So it looks kind of like this. Now, some of you might think, hey, that looks like a V. And here's the thing. You're close. It might look like a V, but here's the thing. It is not a V. As we get into more precise things, we'll see how it's not a V, but it's more of a U. This is all curved. Don't make any sharp points here. It's all curve. Looks more like a U. And this U shape, this is a quadratic. A quadratic is anything that is squared. X squared is a quadratic, so this is a quadratic, but the shape itself is called a parabola. Parabola. A parabola. And that's what Unit 8 is going to be all about. Actually, Unit 8 and 9, the rest of the year. Not the rest of it, but there's going to be a lot of this is going to be about parabolas. All right, so we're going to get more into parabolas, and the way we're going to do that is I want you to write down 2 things really quick. The first thing I want you to write down is Desmos, DESMOS.com, and then I want you to write down y equals ax squared. I showed you a little bit about x squared. They call it a parent graph because nothing else has happened to that or anything. But I want you to do y is equal to ax squared and pull out your Chromebook, and I want you to go to Desmos.com. Go ahead and press pause if you need to. Pull out your Chromebook. Everybody get to Desmos.com. Looks something like this. All right. Hopefully you're back now. Press start graphing. I'll flip my computer around real quick. So, Desmos.com is going to graph this for us, and we are going to type this in. First thing I want you to do is down here in the lower left, I want you to press Show Keyboard. Click on that, and this whole math array should pop up. We're going to need that. You could go and click it in just like a calculator, or you could use your keyboard and put in, we're going to put in y equals ax squared. Now, the way we do squared is there's these buttons down here. This one that says a squared, if you hit that, boom, it puts a little squared there. That's it. But then we're going to go a step further, and what I want you to do is I want you to see where it says add slider. Click that. Click A. And look at this. It gave us a little slider. So what I want you to do is kind of play with that. Look what A does. I want you to take a minute or two, slide A, see if you notice a pattern. What happens with A? Go ahead and hook that up. Play with that. All right, you back? Great. Sliding it. I don't know if you notice this. Check this out. When A is 2, 1, 2, it opens up. It changes the shape of it, right? It gets narrower, it gets wider. But when does it open down? it goes down when it's negative. So let's pull out our notes here. Check this out. A is going to dictate two things. Well, you don't want that. You want this. It controls the shape, which we'll talk more about the shape later. Right now, just know that it gets wider or narrower. We'll talk about how later. But it does the shape and it does the orientation. What do you mean by that, Smith? Orientation. Check this out. It either goes and opens up like this. Put little arrows on it because this goes up and up forever. It either goes and opens up or it opens down. Now, when did it open up and when did it open down? Well, hopefully you noticed that the parabola opens up when A is positive. When A is positive, it opens up like this. But when A is negative, it opens, you can't see what I'm trying to do. It opens down like that, right? It goes down. So if A is positive, it opens up. If A is negative, it opens down. All right, I need you to know that. And then I need you to know one more thing. Another thing we're going to talk about is a thing called, I'm going to go, if you got room, go ahead. You don't need a lot of room. But we're going to talk about zeros, roots, solutions, and x-intercepts. Zeros, roots, solutions, and x-intercepts. Here's the thing, y'all. All of these things mean the same thing. X-intercepts are solutions. X-intercepts are roots. X-intercepts are zeros when we're talking about quadratics. I'm going to use those words interchangeably. So just heads up on that. What are you talking about, Smith? What does this look like? It looks like this. We're going to make 3 coordinate planes. Sorry for my error marks. 3 coordinate planes. We're just going to do a quick little sketch here. Let's hook up this first one. We're just going to draw a parabola that opens up. Zoop, zoop. This parabola here has 2 x-intercepts. See that? Where it crosses the x-axis. This has 2 solutions, or 2 zeros, or 2 roots, or 2 x-intercepts. They all mean the same thing. All right, this one, I want you to draw a parabola like this. How many times does this parabola go and touch the x-axis? It don't never do it, Smith. You're right. So this has no solution. This has no solution. So I gave you a third scenario. It's in the middle. What is between 2 solutions and no solutions? I'm hoping you realize that it is 1 solution. But can you draw a picture of what 1 solution would look like? Try it. Hopefully, you come up with something like this. Hopefully you come up that there's a parabola that comes down, and then it goes bounces off the bottom there, and it hits it right there, that bottom point. Hey, let's talk about that bottom point. Actually, yeah, can I back it up? So there's 2 solutions, there's 1 solution, there's no solution. Sorry, I'm going on 2 different things right here. There's a number of solutions, what that looks like. But let's go back to the beginning of notes. That bottom point, this bottom point here is called a vertex. Let me go up here. This point right here is called a vertex. Now, when the vertex is on the bottom, is that a maximum or is that a minimum, do you think? When the vertex is at the bottom, that is a minimum. When the vertex is on the top, that is a maximum. My time's about to run out. I'm going to have another video for you in just a moment. Smith, pause.